Today we'll study multiple summations in binomial theorem. So over the years I have seen many students and teachers struggle with these multiple summations, particularly in the case of binomial theorem. So we'll discuss two separate cases. Now the case one, which is very simple, and case one is when the variables are independent. Say for example, suppose I have this double summation where it says the value of I varies from 1 to n and the value of j varies from 1 to n, and it's a product of fi into fj. So what I'll do is, I'll start putting the value of I. So if I put I as 1, so I'll get f1, and then this summation, which is summation j varies from 1 to n, and that is fj. Then if I'll put I as 2, I can write f2, and this entire summation j varies from 1 to n, fj. I'll continue up to fn, and then summation j varies from 1 to n, and then fj. Now I can take this expression common. So if I'll take it common, so then I'll get f1 plus f2 plus fn, and then it'll be summation j varies from 1 to n, and there'll be fj. Now this summation is actually nothing but it is summation I varies from 1 to n fi into summation j varies from 1 to n into fj. So when the two variables are independent, then we have no problem in solving such problems, because then in that case, if I have this double summation which is from I1 to n, j1 to n, fi into fj, what I'll simply do is I'll express it as summation fi into summation fj. Now say for example, suppose I have this question where I need to find out value of I varies from 0 to n, value of j varies from 0 to n, and value of k varies from 0 to n, and I need to find this product, which is nCi into nCj into nCk. Now when I look at all the three products, so all these three variables, they are independent, and we have separate expressions for I, j and k. So I can write it as summation I varies from 0 to n, nCi into summation j varies from 0 to n, nCj, and summation k varies from 0 to n, and nCk. Now we know that summation I varies from 0 to n nCr, it is nC0 plus nC1 plus nCn, so that is 2 to the power n. So the value of this expression will be 2 to the power n. Now it will be again the same summation from nC0 to nCn, again it will be 2 to the power n, and this again will be 2 to the power n. So answer to this question will be simply 8 to the power n, or 2 to the power 3n. So in case of independent variables, summation is very simple, so there is nothing much to do. Find triple summation I varies from 1 to infinite, j varies from 1 to infinite, k varies from 1 to infinite, 1 upon a to the power I plus j plus k. So I can actually express it as I varies from 1 to infinite, j varies from 1 to infinite, and k varies from 1 to infinite, 1 upon a to the power I into 1 upon a to the power j into 1 upon a to the power k. So it is a case of multiple summation when the variables are independent. So what I'll simply do is I'll simply express it as summation I varies from 1 to infinite, 1 upon a to the power I into j varies from 1 to infinite, 1 upon a to the power j into summation k varies from 1 to infinite, 1 upon a to the power k. Now each of the series is nothing but a geometric progression. So it is 1 upon a plus 1 upon a square plus 1 upon a cube up to infinite, and since mod of a is greater than 1, then 1 upon mod a is less than 1. So this infinite geometric progression, it converges, and its sum is a, which is 1 upon a upon 1 minus r, which again is 1 upon a. So if I'll simplify, I'll get this result as 1 upon a minus 1. So this first one, it'll be 1 upon a minus 1. Second one, it'll also be a minus 1. And the third one, 1 upon a minus 1. So answer to this question is a minus 1 to the power minus 3. Now the questions become little more interesting when we consider the case of dependent variables. So we'll have multiple summation, and in that case the variables, they are not independent but dependent. Say in this example, it says this summation, this double summation, the variable I, it starts from 0, it is less than j, which is less than or equal to n. So here I and j, they are not exactly independent. So in this case, what you can do is, I know that this value of I will start from 0, and this value of j will start from a number which is 1 greater than I, and it goes up to n. So I'll consider the case, suppose when I is 0. In that case, the value of j will lie between 0 and n. So in each of this case, I can write this expression as C0 plus C1 plus C0 plus C2, C0 plus C3, and then C0 plus Cn. Now if I take I as 2, I as 1, so in that case the value of j varies from 2 to n. So I'll write it as C1 plus C2, C1 plus C3, and it'll go up to C1 plus Cn. Again for I equals 2, so here the value of j will lie between 3 and n. So I'll write C2 plus C3, C2 plus C4, and then C2 plus Cn, and it will continue up to when the value of I is actually n minus 1. So in that case, I can write it as simply, and the value of j will be greater than n minus 1 but less than or equal to n. So in that case, I'll get only one term, and that should be Cn minus 1 plus Cn. Now I have to find the sum of all these terms. Now if I look at this series, then how many times do I get this C0? So there is no C0 in any term where I is 1 or greater than 1. So I'll get C0 only from the first expression. So I see C0 with each of these terms. So actually C0 in this expression, it occurs n times. So I'll write n times C0. What about C1? So I see C1 here, and then I see C1 here for each of the term, and then for all other terms there will be no C1. So in this expression there are n minus 1 terms with C1, and there is one C1 term here. So again I get n times C1. Again is the case same for C2. So for all these expressions now Cn, so Cn, 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 and Cn for each of these n rows. So again it will be n into Cn. So I'll take this n common, and I'll get C0 plus C1 plus Cn, so which is n, and the summation of this series is 2 to the power n. So answer to this double summation Ci plus Cj will be n into 2 to the power n. So let us consider another problem, and which is double summation I is greater than 0 but less than j, which is less than or equal to n, and then it is I plus j, Ci plus Cj, and it is given that double summation of Ci plus Cj is n into 2 to the power n. So in the video just prior to this one, we have proved this result, and which was Ci plus Cj is n into 2 to the power n. So we'll find the answer to this question using this result. So what I'll do is, I'll say, suppose this result is equal to some series S. Now I know that there is a symmetry in the question, and if I interchange I and j, the question will remain the same. So what I'll do is, I'll reverse the series. And how do I reverse the series? So I'll reverse the series with the expression, I'll replace I with n minus I, and I'll replace j with n minus j. So I can write the same series as summation I is less than j is less than equal to n, and here I can write n minus I plus n minus j, and there will be nCn minus I plus nCn minus j. So I'll write this as double summation I is less than j is less than equal to n, and it will be 2n minus I plus j, and here it is nCn minus r is same as nCr, so it will be nCi plus nCj. Now I'll split this summation in two parts, so I'll write this as summation, so there will be 2n into nCi plus nCj, and then minus double summation, and then it'll be i+j nCi plus nCj. Now what I can do is I can take this 2n out, so I'll write it as 2n and then this double summation, and it will be nCi plus nCj, and here I know it is i+j into nCi plus nCj. So i+j into nCi plus nCj is actually nothing but s. So I can write this as s. So I'll take this s on the left hand side, so I can write it as 2s, and this is 2n, and this summation, so it's already given that this summation is n into 2 to the power n. So I'll write it as n into 2 to the power n. So here 2 and 2 will cancel. So this sum will be n square into 2 to the power n. So answer to this series is n square into 2 to the power n. We need to find the sum of this series, which is double summation, then I is greater than 0, which is less than j, and which is less than or equal to n, and I need to find this product, which is Ci into Cj, and it is given that nc0 square plus nc1 square plus ncn square is 2ncn. So this result we have already done in one of the previous videos. Now what I'll do is I'll take up this expression and I'll try and find out if the value of I is 0, then in that case the value of j, it starts from 1 because it is greater than I, and will be less than or equal to n. So in that case I'll get this product as C0, and then it will be C1 plus C2 plus Cn. Now if the value of I is 1, the value of j varies from 2 to n. So in that case I'll have C1, and then it will be C2 plus C3 plus Cn. For I equals to, j varies from 3 to n. So then it will be C2, and it will be C3, C4, and then Cn. And then for I equals n minus 1, so I is actually less than n, right? So the highest value of I will be n minus 1. So in that case, the value of j will simply be n. So that should be Cn minus 1 into Cn. Now, if I look at these products, C0, C1, C0, C2, C0, Cn, C1, C2, C1, C3, C1, Cn, C2, C3, C2, C4. So it's a product of all the binomial coefficients with themselves when I is unequal to j. So basically, if I'm going to add all of them, so then this result is summation of the product of all binomial coefficients Ci into Cj when I is unequal to j for all the values of I and j that lies between 0 and n. So it will be C0, it will be multiplied with every binomial coefficient from 1 to n. C1, it will be multiplied with every coefficient from 2 to n. So I need to find out this product. Now, how do I find that? So I'll begin with our basic series expansion, and that was C0 plus C1 plus C2 plus Cn, and we know that this series expansion is 2 to the power n. So what I'll do is I'll simply square this series. So if I'll square the series, I can write it as C0 square plus C1 square plus C2 square plus Cn square plus 2 times. Now here I'll get these terms C0 C1, C0 C2, C0 Cn, C1 C2, C1 C3, C1 Cn, C2 C3, C4, and then Cn minus 1 Cn. So basically I'm getting all these terms in the series in this product. So I'll write it as twice summation I is unequal to j, Ci into Cj, and that is 2 to the power 2n. Now it is also given that C0 square plus Cn square is 2nCn. So if I'll put this value as 2nCn, then I can find this value as, then I can write this value as double summation I is unequal to j, Ci into Cj. So that will be 2 to the power 2n minus 2nCn And then we have this 2 here. So whole divided by 2. So answer to this series, or the value of p will be 2 to the power 2n minus 2nCn divided by 2. Another method to solve double summation problems for dependent variables is matrix method. So I'll take up an example. Say for example, I need to find this double summation which is Ci into Cj when I is greater than or equal to 0 but less than j, which is less than or equal to n. So I need to find the product of all these binomial coefficients Ci into Cj when the value of I is less than j, and then we'll need to add them. So what I'll do is, I'll rather find this sum which is easy, and that is double summation I varies from 0 to n, j varies from 0 to n, Ci into Cj. Simply because it is a product or it is a double summation with independent variables. So I can actually write it as double summation I varies from 0 to n, Ci, and summation j varies from 0 to n, Cj, and which is essentially nothing but C0 plus C1 plus Cn into C0 plus C1 plus Cn. And we know that this product C0 plus C1 plus Cn, this sum is 2 to the power n, and the same way it is again 2 to the power n, so I can write it as 2 to the power 2n. So the product of all the coefficients starting from 0 to n, it will be C0 square, C0 C1, C0 C2, C0 Cn, and there will be 2 to the power 2n. Now another way of expressing this product of coefficients is using matrices. So what I'll do is, I'll write this product Ci into Cj. Here in the rows, I'll write coefficients of I, C0, C1, C2 and Cn. And here in the columns, I'll write coefficients for j, C0, C1, C2 and Cn. And I'll start multiplying them. So C0 into C0, C0 square, C0 C1, C0 C2, C0 Cn. In the same way, C1 C0, C1 square, C1 C2. And this series will continue up to Cn into nCn, which will be Cn square. So this matrix has all the terms possible when Ci is multiplied with Cj, provided the value of I varies from 0 to n and the value of j varies from 0 to n. Now let us look at terms in this principal diagonal. Now for all these terms in the principal diagonal, it is C0 into C0, C1 into C1, C2 into C2. So that is, for all the elements in principal diagonal, the value of I is same as value of j. So it is C0 C0, C1 C1 and Cn Cn. Now for all the elements in the upper triangle, now when I is 0, j starts with 1, it goes all the way up to n. When I is 1, j starts with 2. So this is the condition when I is less than j. So for all the elements in the upper triangle, I is less than j. And the same way, for all the elements in the lower triangle, the value of I will be greater than value of j. So this double summation of product, which is Ci into Cj, it will have three kinds of terms. First, all the terms where value of I is same as value of j. Secondly, the terms where I is less than j. And then all the terms where I is greater than j. So I can express this double summation as I varies from 0 to n, j varies from 0 to n, Ci into Cj as this summation, which is C0 square plus C1 square plus C2 square plus Cn square, and there will be Ci square when I is equal to j. Now plus this sum, which is Ci into Cj for all the elements in the upper triangular matrix. So there will be when I is less than j, and then plus sum of all the products Ci into Cj when I is greater than j. That is sum of all the terms in the lower triangle. Now we know that for any term in the lower triangle, there is a corresponding term in the upper triangle. So here it is C1 C0, it is C0 C1. Here it is C2 C0. Here it is C0 C2. C2 C1. Here will be C1 C2. So for any term in the lower triangle, which is Ci into Cj, we have a corresponding term in the upper triangle, and there will be Cj into Ci, and these two terms, they will be same. So basically all the terms across this diagonal, they are symmetric. So I can say that this double summation Ci into Cj when I is less than j is same as double summation Ci into Cj when I is greater than j. So essentially the sum of all these terms when I is less than j is same as sum of all the terms when I is greater than j. Now we have already worked out this product. So this I varies from 0 to n, j varies from 0 to n, Ci into Cj is 2 to the power 2n. Now this series, C0 square plus C1 square plus Cn square, it's a standard series. We have already worked it out. So the sum of the series is 2nCn, and then I can write it as 2 times summation I is less than j Ci into Cj. Now I can write this product. So this is double summation I is greater than 0 but less than j, less than equal to n, Ci into Cj will be 2 to the power 2n minus 2nCn and then divided by 2. So answer to this series is 2 to the power 2n minus 2nCn divided by 2. So we can find this double summation using matrix method also. Now we'll come to the second part of the question, which is find q, which is double summation Ci minus Cj whole square. And in the first part, in the previous video, we have done that the value of this product Ci into Cj double summation will be 2 to the power 2n minus 2nCn whole divided by 2. Now what I'll do is I can write it as summation I is greater than 0 but less than j is less than equal to n, and it will be Ci square plus Cj square minus 2 times Ci into Cj. So I'll write it as double summation I is less than j is greater than equal to 0 less than equal to n, and it will be Ci square plus Cj square and then minus 2 times double summation I is less than j is less than equal to n, Ci into Cj. Now we'll try and solve this one. So for this one, when I is 0, the value of j varies from 1 to n. When I is 1, j varies from 2 to n. And when I is n minus 1, then the value of j is n. So I can write it as C0 square plus C1 square, C0 square plus C2 square, C0 square plus Cn square, and here will be C1 square plus C2 square, C1 square plus C3 square, C1 square plus Cn square, and then finally it will be Cn minus 1 square plus Cn square. So like a similar question we have done in one of the previous videos, and that was C0 plus Ci plus Cj. So using the similar argument, we know that now C0 square, it appears in n of these terms. So it will be n times C0 square. Again C1, here we have n minus 1 terms, and we have one more C1 square. So again it will be n times C1 square. Again for C2, there will be C2 square, there will be n terms, and again for Cn, there will be n terms. So this series is actually n times C0 square plus C1 square plus Cn square and then minus 2 times. Now what about this series? This series is actually nothing but it's p. So I'll write it as 2p. So the value of this expression q will be, now this is n times, and we know that C0 square plus C1 square plus Cn square is 2nCn. So it will be 2nCn and then minus 2 into, what is the value of p? Value of p is 2 to the power 2n minus 2nCn whole divided by 2. So I'll cancel this 2. So I can write it as n plus 1 2nCn minus 2 to the power 2n. So the value of q will be n plus 1 2nCm minus 2 to the power 2n. Find the value of this double summation. Now k varies from 1 to n and r varies from 0 to k, r into nCr. So what I'll do is, I'll write it as summation k varies from 1 to n, and it is summation r varies from 0 to k, and I'll write r, it will be factorial n, factorial r, and then it will be factorial n minus r. Now I'll cancel this r with factorial r. I can write it as summation k varies from 1 to n, and then summation r varies from 0 to k. So if I'll cancel this r, I'll get factorial r minus 1 and factorial n minus r. Now since I have this r minus 1 and it is still n minus r, so I'll express it as n into factorial n minus 1. So I'll take this n out of this summation, so I can write it as n into, now this summation k varies from 1 to n, and this summation r varies from 0 to k, and here I'll get n minus 1 c r minus 1. Now when the value of r is 0, in that case this term will be 0. So what I'll actually do is, I'll start this summation not from 0, I'll start this summation from r equals 1. So now first I'll put in the value of r. So I can write as n will be summation k varies from 1 to n, and I'll get it as n minus 1. When the value of r is 1, it is 0. n minus 1 c1, and this series will continue up to n minus 1 c k minus 1. Now we need to find the summation of this series. Now this series, so there will be this n, and then when k is 1, so it'll start with n minus 1 c0 and it'll end at k minus 1, which is n minus 1 c0 itself. So for k equals to 1, I'll get only one term, and there'll be n minus 1 c0. Now when the value of k is 2, so in that case this expression will be 2 minus 1, which is n minus 1 c1. So there I'll get two terms, and there'll be n minus 1 c0, n minus 1 c1. Now for k equals 3, it'll go up to n minus 1 c2. So then I'll get n minus 1 c0 plus n minus 1 c1, n minus 1 c2. And finally, when the value of k is n, in that case this series will go all the way up to n minus 1. So there I'll get n minus 1 c0, n minus 1 c1, and n minus 1 c n minus 1. So now what I'll do is, I'll write the series sum as s equals, so there'll be this n, and then I have n minus 1 c0, n minus 1 c0, n minus 1 c0 in each of the factors. So that is, I'll have this n minus 1 c0 n times. So I'll write n times n minus 1 c0. Then I'll have n minus 1 c1 in each of the factor except the first one. So then it'll be n minus 1, n minus 1 c1, n minus 2, n minus 2 c2, and it'll continue up to, and the last one will be 1 into n minus 1 c n minus 1. So now when I look at these coefficients, n minus 1, n minus 2, I know it's an AP. So I'll use reversing technique. So I'll reverse the series. I'll write it as n, and here will be 1, and nCr is same as nCn minus r. So I'll write n minus 1 c0. Now just before that, it will be 2 times nCn minus 2. So there will be n minus 1 c1, and then I'll continue this way, and finally it will be n, and again nCr is same as nC n minus r. So now I write the two series. So I'll write 2s. So I'll take this n common, and when I'll add all the terms, I'll get n plus 1 here, I'll get n plus 1 here, I'll get n plus 1 here. So I'll get this n plus 1 common from each and every term. So I can write it as n into n plus 1, and then I'm left with this series, which is n minus 1 c0, n minus 1 c1, and n minus 1 c n minus 1. So this is 2s n, and it'll be n plus 1, and the sum of this series is nothing but 2 to the power of n minus 1. So I'll write s as n plus 1, 2 to the power of n minus 2. So the sum of the series is n plus 1, 2 to the power n minus 2. We get another interesting problems in binomial theorem, which are of the form when we have the summation which is defined as nCm and mCp, where this p varies from 1 to n and m varies from p to n. So what we'll do is we'll first try and simplify this term. So I'll write it as summation p varies from 1 to n and m varies from p to n. So I'll write factorial n, factorial m, factorial n minus m, and here I'll write factorial m, factorial p, and factorial m minus p. So I'll cancel this factorial m with factorial m, and then I'll write it as summation p varies from 1 to n, summation m varies from p to n. So it is factorial n. I'll take this factorial p here. So I'll write it as factorial p, and I'll try and make it as nCp. So I'll multiply and divide it with n minus p. So factorial n minus p here, and then I'll have to multiply it with n minus p factorial also. So then here will be m minus p factorial, and then this one, which is n minus m factorial. So what I've done is I have rearranged these factorials. So now when I look at this term, I can write it as summation p varies from 1 to n, m varies from p to n. Now this is nothing but it is nCp, and here it will be n minus p, m minus p, and if I'll subtract them, I'll get n minus m. So it is nothing but it is n minus pc, m minus p. So now what I've done is previously it was m and m here, like for both the terms, but in this case I have separated the term containing m. So now it will be a little easy for me. So now I can take this nCp out. I can write summation p varies from 1 to n, and then it will be nCp, and then it will be the series which is the value of m starts from p and ends at n, and it is n minus pc, m minus p. So first I'll try and find the sum of the series. So this series will be summation p varies from 1 to n, nCp, and if I'll put value of msp, I'll get n minus p c0, n minus p c1, n minus p c2, and it'll continue up to n minus p c n minus p. So which is nc0 plus nc1 plus ncn, and which is in fact nothing but 2 to the power n. So I can write it as summation, the value of p varies from 1 to n, and will be nCp, and be 2 to the power n minus p. Now I need to find the summation, which is the value of p varies from 1 to n, nCp, and 2 to the power n minus p. Now what I'm going to do is I'm going to also write it as 1 to the power p. So now if I look at this, it seems like it is nCr, a to the power n minus r, b to the power r, and still this first term is missing. So because the series starts from p equals to 1, so I need to start it from p equals 0. So actually I'll write it as summation p varies from 0 to n, and then nCp 2 to the power of n minus p into 1 to the power of p, and then because we have added one term, I have to subtract that term also. So minus nc0 2 to the power n and 1 to the power 0. So I can write this sum as summation p varies from 0 to n, nCp 2 to the power of n minus p into 1 to the power of p, and then minus will be 2 to the power of n. Now this is nothing but the expansion of a plus b to the power n. So I'll write it as 2 plus 1 to the power n minus 2 to the power n. So the answer to this series will be 3 to the power n minus 2 to the power n. Now in this question it is given that the value of this series is equal to 19. So I can write 3 to the power n minus 2 to the power n equals 19, and I need to find the value of n. Now I know that 3 cube it is 27 and 2 cube it is 8. So if I take n as 3, then I'll get 3 cube minus 2 cube, and this value will be equal to 19. So in this case the value of n should be 3. Now this question is similar to the one which we have solved in the previous video. So here again we'll have p varies from 1 to 16, m varies from p to 16. This is 16 cm, and mCp. So again I'll write it as summation p varies from 1 to 16 and summation m varies from p to 16. So I'll write factorial 16, factorial m, and then factorial 16 minus m, and here will be factorial m, factorial p, and then it will be factorial m minus p. So I'll cancel this factorial m and factorial m, and I'll take this p here. So I'll write it as summation p varies from 1 to 16, m varies from p to 16. So I'll write factorial 16. I'll take this p with factorial 16, and I want to change it to 16cp. So I'll multiply and divide it with 16 minus p factorial, and then I'll have to multiply with 16 minus p factorial, and then it'll be m minus p, 16 minus factorial m, 16 minus m. So I can write it as summation p varies from 1 to 16, m varies from p to 16. So this is 16cp, and it will be 16 minus p, c, m minus p. Now we have separated n and this term. So now it becomes independent. So I can write it as summation p varies from 1 to 16, and this is 16cp, and then this summation, which is the value of m varies from p to 16, and will be 16 minus p, c, m minus p. So this series is in fact nothing but summation of p varies from 1 to 16, 16cp, and then will be 16 minus p, c0, 16 minus p, c1, and then 16 minus p, which is 16 minus p to c, 16 minus p, so which is nc0 plus ncn. So that should be summation p varies from 1 to 16, 16cp, and it will be 2 to the power 16 minus p. So I'll also write it as 1 to the power p. So which is nCr a to the power n minus r into b to the power r. But here the summation starts from 1. I need the summation to start from 0. So I'll add one more term and I'll subtract that term also. So I'll start with from p equals to 0 to 16, 16cp, 2 to the power 16 minus p, and then 1 to the power p. And because you have added this term when the value of p is 0, so I have to subtract that term also. So then it will be 16c0, 2 to the power 16 into 1 to the power 0. Now this is nothing but it is binomial expansion of a plus b to the power n, and here it will be 2 to the power 16. So answer to this question will be 3 to the power 16 minus 2 to the power 16. So this is how we solve these questions. Now we'll discuss a triple summation problem. And the problem is we need to simplify the series, which is nCp, pCm, and mCk, where this value of k is greater than or equal to 0, m is greater than or equal to k, and p is greater than or equal to m but less than or equal to n. So what I'll do is first I'll split this summation. So I'll write summation, and then the value of k starts from 0 and its maximum value will be n. Now for this m, its value starts with k and goes up to n, and for this p, the minimum value is m and it goes all the way up to n. And I can write it as nCp, pCm, and mCk. So first I'll simplify these two terms. So I'll write them as factorial n, factorial p, factorial n minus p, and then here will be factorial p, factorial m, and factorial p minus m, and I'll keep this mck as it is. Now I'm going to cancel this p with p, and I'll also take this factorial m with factorial n. So double summation for these kind of problems we have done in one of the previous videos. So I'll provide the link below. So if you want, you can have a look at that video. So now it will be triple summation, and then I'll write factorial n upon factorial m, and here I'll write n minus p factorial and p minus m factorial. Now I want to change it back to binomial coefficient form. So I'll multiply it with factorial n minus m, and I'll also divide it with factorial n minus m. So now I can write it as summation Now this is nCm, this is n minus m, c, p minus m, and that's mCk. So now I can write it as summation k varies from 0 to n, m varies from k to n, and p varies from m to n. So this is nCm. I'll take this term first, mCk, and then I'll have n minus m, c, p minus m. So first I'll handle this summation because we have separated p. So I can write it as double summation k varies from 0 to n, m varies from k to n, and then I'll write nCm into mCk, and then I'll have this summation which is summation p varies from m to n, and then it will be n minus m, c, p minus n. So if I'll simplify this summation, I can write it as summation k varies from 0 to n, summation m varies from k to n. So this is nCm, mCk, and here I'll write, so if I'll put p as m, I'll get this as n minus mc0, then n minus mc1, and this series will continue till the value of p is n. So there'll be n minus m, c, n minus m. So this series is actually nothing but nc0 plus nc1 plus ncn. So I can write it as double summation k varies from 0 to n, m varies from k to n, nCm.mCk, and then here I'll have 2 to the power n minus m. So now I need to solve this double summation. Now I'll take this double summation here. I'll write double summation k varies from 0 to n, m varies from k to n, and here I'll try and simplify this term. So I'll write factorial n upon factorial m factorial n minus m into factorial m factorial k factorial m minus k into 2 to the power n minus m. Now here again I'll cancel this factorial n and then I'll rearrange. So if I'll rearrange, I'll write it as k varies from 0 to n, m varies from k to n. So here I'll get factorial n. I'll take this factorial k here, and then I'll write n minus m factorial, m minus k factorial. Now here I want to make it as nCk. So I'll multiply and divide it with n minus k factorial, and then into 2 to the power n minus n. So now I can write it as summation k varies from 0 to n, summation m varies from k to n, and this is nCk, and it is n minus k, c, m minus k, 2 to the power of n minus n. So now I'll split this summation in m. So I'll write summation k varies from 0 to n, and there'll be nCk, and then I'll write summation m varies from k to n, and there'll be n minus k, c, m minus k, and 2 to the power of n minus m. So I can actually express it as summation k varies from 0 to n, and will be nCk, and here if I'll put the value of m as k, so I'll get n minus k c0 and 2 to the power of n minus k. Now if I'll put m as k plus 1, I'll get it as n minus k c1 and 2 to the power of n minus k plus 1, and this series will continue. Final value of m will be n. So finally we'll get n minus k c n minus k into 2 to the power of 0. So there'll be 2 to the power of n minus n, there'll be 0. Now this is nothing but nc0 x to the power n, nc1 x to the power n minus 1, nCn x to the power 0. So this is nothing but it is series sum of, so it will be nCk, and it is binomial expansion of a plus b to the power n. So here will be 2 plus 1 to the power n minus k. So I can write it as summation k varies from 0 to n nCk 3 to the power of n minus k. Now I can also write it as summation k varies from 0 to n nCk 3 to the power of n minus k into 1 to the power of k. So now this is nothing but nCr a to the power n minus r and b to the power r, where the value of r varies from 0 to n. So this again is nothing but a binomial expansion of a plus b to the power n. So I'll simply write it as 3 plus 1 to the power n, and which will be 4 to the power n. So answer to this triple summation is simply 4 to the power n. So let us take up another problem in triple summation, and that is triple sum of 1 when I is greater than or equal to 0, j is greater than I, k is greater than j, and k is less than or equal to n. So I'll write it as summation. Now this value of k, it should be greater than j, so it will start with j plus 1 and it will go all the way up to n. Now value of j, it is greater than I, so it will start with I plus 1, and the maximum value it will have is j should be less than k, so here it will be n minus 1, and the minimum value of I it will be 0, and its maximum value should be less than maximum value of j, and it should be n minus 2, and we need to find this triple sum of 1. Now if I'll find this summation 1, so I can write it as summation I varies from 0 to n minus 2, j varies from I plus 1 to n minus 1, and here it will be 1 plus 1 plus 1, so number of summation times, and there will be n minus j plus 1 plus 1, so that should be summation I varies from 0 to n minus 2, j varies from I plus 1 to n minus 1, and it should be n minus j. I can also express it as summation I varies from 0 to n minus 2, j varies from I plus 1 to n minus 1, and then I'll write it as n minus j c1, because I know nc1 is simply n. So if I'll put the value of j, I can write the series as summation I varies from 0 to n minus 2, and then if I'll put j as I plus 1, I'll get n minus I minus 1 c1, n minus I minus 2 c1, n minus I minus 3 c1, and we'll continue. So last value of j will be n minus 1, so there will be 1 c1. So before that I'll have 3 c1 plus 2 c1 and plus 1 c1. So that's my series. So what I'll do is I'll replace this 1 c1, because I know 1 c1 is simply 1. So I'll replace 1 c1 with 2 c2. So nCn is simply 1. So if I use the property n same and r differs by 1, so it will be 3c2. Now 3c1 plus 3c2, there will be 4c2. So in the same way, if I'll solve the series, then I'll write the series as summation value of I varies from 0 to n minus 2, and here it will be, the last one should be n minus I minus 1 plus 1, and then c2. So minus 1 and plus 1 will cancel. I'll get the series as summation I varies from 0 to n minus 2, and that should be n minus I c2. Now I'll try and solve this series. Now for this series, I'll write it as, so if I'll put I as 0, I'll get it as nc2. Then for I as 1, n minus 1 c2, n minus 2 c2, and then finally when I put I as n minus 2, I'll get it as 2c2. So I'll write 4c2 plus 3c2 and plus 2c2. Now again nCn is 1. So I'll write 2c2 as 3c3, because for both of them the value is 1. So if I'll use the property again here, n is same, r differs by 1. So then it will be 4c3. Now 4c2 plus 4c3 will be 5c3. So if I'll continue in this fashion, then finally I'll get n plus 1 c3. So the answer to this triple summation is n plus 1 C3. So now let us take another question in multiple summation, and the question is summation of 1, and we need to prove that it is nC4 plus twice nC3 plus nC2 where I is greater than equal to 1, j is greater than equal to I, k is greater than j, w is greater than equal to k, and less than or equal to n. So I'll split the summation. So I'll write it as summation. Now this w, it starts with k and it goes all the way up to n. Now this k is in fact greater than j. So k starts with j plus 1 and it goes all the way up to n because there is an equality sign here. Now this j is greater than equal to I. So this j starts with I and it is less than n. So it'll go to n minus 1 and this value of I, it'll start with 1 and again it'll go to n minus 1. And we need to find sum of this series. Now first I'll find this sum. So this sum is sum of 1 plus 1 plus 1 from k to n. So that should be summation n minus k plus 1. So I can also express it as triple sum of n minus k plus 1 C1 because I know that nC1 is same as n, and here the value of k varies from j plus 1 to n. So I'll simplify this summation. So I'll write it as double sum where I varies from 1 to n minus 1, j varies from I to n minus 1, and here the first value of k will be j plus 1. So if I'll put k as j plus 1, so 1 and 1 will cancel. I'll get n minus j C1 and then n minus j minus 1 C1, and finally if I put k as n, I'll get this as 1 C1. So here I'll get 3 C1 plus 2 C1 plus 1 C1. Now what I'll do is, I know that 1 C1 is 1 and so is 2 C2. 2 C2 is also 1. So I'll use the binomial coefficient property, in which is if n is same and r differs by 1, it is n plus 1 CR. So I'll write it as 3 C2. Now 3 C1 plus 3 C2, again n same, r differs by 1. So that should be 4 C2. So if I continue in this fashion, I can write it as summation I varies from 1 to n minus 1, j varies from 1 to n minus 1, and here it will be n minus j plus 1 C2. So if I'll simplify the series, I'll get this result as n minus j plus 1 C2. Now I'll start expanding in terms of j. So I'll write it as summation I varies from 1 to n minus 1. So I'll put the value of j as I. So here I'll get n minus I plus 1 C2. If I'll put j as I plus 1, then I'll get n minus I C2. I'll continue up to, so if I'll put j as n minus 1, so here n and n will cancel. So here I'll get 2C2. So I'll continue up to 2C2. So I'll get 4C2 plus 3C2 and plus 2C2. Now again, what I know is 2C2 is simply 1 and so is 3C3. So I'll replace 2C2 with 3C3. Now 3C3 plus 3C2, so there'll be 4C3. 4C3 plus 4C2, there'll be 5C3. So if I'll continue in this fashion, I can write it as summation I varies from 1 to n minus 1. And here if I'll add one more, I'll write n minus I plus 2, and that should be C3. So it changes to n minus I plus 2 C3. So now I'll expand this series. So now if I'll put I as 1, I'll get it as n plus 1 C3, then n C3, n minus 1 C3, and finally if I'll put I as n minus 1, so I'll get it as 3C3. So I'll write 5C3 plus 4C3 plus 3C3. Now 3C3 is again 1, so I'll replace it with 4C4. Now n same, r differs by 1, so there'll be 5C4. Now again n same, r differs by 1, 6C4. So finally in the end, I'll get n plus 2 C4. So answer to this summation is n plus 2 C4. Now, if I look at the series on the right hand side, so on the right hand side, I have this expression which is nC4 plus 2 times nC3 plus nC2. So I'll write it as nC4 plus nC3 plus nC3 plus nC2. So now n same, r differs by 1. So I'll write n plus 1 C4 and here will be n plus 1 C3. Now here again n is same and r differs by 1. So there will be n plus 2 C4. So the series on the left hand side is n plus 2 C4 and the series on the right hand side is also n plus 2 C4. So this is how we prove this given result. If you like the video, consider subscribing and sharing it with someone you know who might benefit from it. Also, the best way to navigate any topic is through a playlist. Simply go to the channel page, click playlist and select the topic you wish to study.